All right, so number 7, this time we want to do composition of functions and find domains. This time we actually have some fractions involved. So let's explain this from the top. So traditionally, when you have composition of functions, now looking ahead in the previous problem, I saw we didn't have fractions or any restrictions, so we didn't have to worry about this. But now that we have fractions, we do have restrictions. So let's find that. So for f of x, we have the function x divided by x minus 6. For g of x, we have the function negative 7 divided by x. So we're going to find the domain for f of x. So for f of x, the domain, x minus 6 cannot be 0, because if so, we would divide by 0. And solving for x, we get that x cannot be 6, because if you add 6 over, this is our domain for f of x. Okay, everything works except for the number 6. Now when we do g, our domain here is x cannot be equal to 0, because we can't divide by 0. And there's nothing to solve here, we just have x cannot be 0. So this being the case, we will use these as part of our domains, and I'll show you how as we move forward. So you start out finding your domain or any restrictions, and from there we're going to start with part A. So part A says we want to do f of g of x. I'm just going to go ahead and translate it to what it means. What this means is I'm going to take the f expression. So it is x on top, which I leave as blank, and then it's x minus 6 on bottom. I'll leave that as blank. In the place of x, we're plugging in the gx equation, which is negative 7 over x. Negative 7 divided by x, negative 7 divided by x. Okay, so this looks like a weird, very, very weird expression. We have a fraction on the top in the numerator, and then we have another fractional expression in the denominator. Okay, so the way that we are going to simplify this is we look at the numerator, we look at the denominator. Both the numerator and the denominator have a fraction. So there's a denominator in the numerator, which is x. There's a denominator in the denominator, which is x. So if you have fractions like this, you're going to find what we call the least common multiple of both the top and the bottom. And in each case, it's x. So to fix this, we're going to multiply this expression by x on top and x on bottom, so that it looks neater. So what we're doing is we're distributing x here, and we're multiplying this by x here. Okay, so when we multiply by x, it cancels out division by x. It's really 7x on top divided by x, which is going to get rid of division. That's the whole reason why we're multiplying by x, is to get rid of division. Okay, so again, how did I come up with that? I had a denominator in the numerator, and in the denominator you find the common denominator between those two, which is x, and once you find that, you multiply it through on top and bottom. So negative 7 times x, which is really just going to cancel out that division by x, and this function is going to simplify to negative 7 on the top, because this crosses out this, multiply by something, divide, it cancels out. Now here we actually distribute the x. So when I multiply x times the negative 7 over x, that just becomes a negative 7. And then you also do, because you have to do distributive property, times both of these, negative 6x, so minus 6x. Okay, so this is your new function right here. Now you have to keep in mind which function did we plug in. Okay, so we plugged in g of x. So I'm plugging in x values. of g of x, we could not use 0 in g of x. So therefore, whenever I plug in g of x and I get this new function, part of my domain is I still cannot use 0. I couldn't use 0 before, and I still cannot use it now that I've plugged it in. Now with my new function, I also have new restrictions. So I need to find out what those new restrictions are that will be added to the ones I already had. Now we don't have to incorporate the original restriction from f because it is not affected. I didn't plug in anything. I plugged in g, not the f equation. So you only carry over the ones that you plug in. So I plugged in this, so I cannot use 0 in that plug-in. And from this one, the denominator cannot equal to 0. So negative 7 minus 6x cannot be equal to 0. We will solve. We will add 7. So we get negative 6x cannot be equal to 7. And divide by negative 6, we get x cannot be equal to negative 7 over 6, or negative 7/6. So we have two numbers that are restricted in our domain, 0 from the original g of x that we plugged in, and negative 7/6 from our composition f of g of x. So when we type in our solution, we can type in the simplified form of the expression. So I'm going to do a division bar, negative 7, arrow down, negative 7 minus 6x. Now I could divide through by negative and just call this all positive, but let's see. I think this may be acceptable. Okay, yeah, it's fine. But you can also divide negative through the top and bottom and write this as positive. And then the domain is the set of all x's such that we're going to say x is not equal to, and we're going to list these two numbers, 0, comma, fraction bar, negative 7 over 6. Up and one on the bottom. I want that on the top. Negative 7 over 6. So those two are in our restrictions. Okay, and we're going to continue and do the rest the same way. So once you have those two original restrictions, you have to keep in mind whichever one you plug in, you carry those restrictions all the way with you. So either I will carry a 0 with me or I will carry 6 with me, depending on which one is being plugged in. Okay. So on part B, we are doing g of f of x, which is g f x, like this. So this time we're plugging in f of x, and the restriction on f of x was x could not be equal to 6. So that restriction is going to come along with whatever we end up with. So the g is what we start with first. G equation was negative 7 divided by x. Now in the place of x, we're replacing that with the fx equation. So that will be x divided by x minus 6. So this time we just have a denominator in the bottom, so we just have a fraction within a fraction. So there's a couple things you can do. You can do the same method we did here, which is multiply top and bottom by the common denominator, which would just be x minus 6. Or you can think of it as keep, change, flip. So you have a fraction divided by a fraction, or a fraction within a fraction. You take the negative 7, you keep that, change division to multiplication, and you flip this expression. So it will be, let's just write this as 7 over 1. So you keep that, change to multiplication, you flip this. So this will be x minus 6 over x. Keep, change, flip. And then we'll distribute and multiply straight across. Negative 7x plus 42 divided by x. Okay, in this expression, finding our domain here, domain x cannot be 0. That's the only thing that will make x 0. And we also have to carry along our 6. So our domain here is x cannot be 0 or 6. And this is our new expression. Simplified, negative 7x plus 42 divided by x. Fraction, negative 7x plus 42. And then on the bottom we have x. And then our domain, x cannot be equal to 0 and 6. All right, so on part C, we're plugging f into itself. And so you still have to keep in mind those previous restrictions. So part C, we're doing f of x. All right, so my f equation is x, which I don't want to write x. I'm sorry, I want to leave a space. And then divided by x minus 6. So in the place of x, I'm replacing with f of x. And that is x over x minus 6 there, and x over x minus 6 here. So again, we had that scenario where we got a fraction in the numerator and the denominator. Common denominator, they're both the same, is x minus 6. So to solve this, we're going to multiply x minus 6 on the top and x minus 6 on the bottom. Whole reason being is it will eliminate the denominator in both cases. So when I multiply x minus 6 here, it leaves me with x on top because it just crosses out the bottom. So just left with x over this. We'll cross out this because you got to distribute here. You got two terms, okay? You got this times this term, this times this term. We didn't have but one term on the top. We've got two separate terms. Separation by a plus or minus sign gives me different terms. I'm sorry, we can't see that, x minus 6. But we're going to be distributing here. It's going to get rid of that and leave me with x. And then distribute here gives me a minus 6x plus 36. And we're going to simplify the bottom. So we have x on top. X minus 6x is a negative 5x plus 36. So here's our expression. Part of my domain was we could not use 6 because that was from f of x. We also have another part of our domain, 5x plus 36 cannot be 0. That's a negative 5x. We will subtract 36, so we get negative 5x equals negative 36. Divide by negative 5, and you get x cannot be equal to 36 over 5. Okay, so we can leave it like this. So part of our domain is we cannot use 6, we cannot use 36 over 5. So our function, division bar, x, and then negative 5x plus 36. And domain, we cannot use 6. We cannot use 36 divided by 5. Okay, let's make sure I haven't made any mistakes. Let me see what are we thinking about. We can't use 6 for sure. Oh, did I not put my x is not equal to? That's what I'm missing. X not equal to. Okay. And then G. we're going to be doing a G composed with itself. So we have G of x. Okay, so the G expression is -7 over x, which we're going to be replacing x with -7 over x. Part of this expression was x cannot be 0. We can do keep, change, flip here. So we have -7 over 1, write that as a fraction. Keep the top, change division to multiplication, flip the bottom. So we get x over -7. And from here, the -7s will divide out, and we're just left with x over 1 or x. In this expression, we will have no restrictions because there's no fractions, square roots, or logarithms. So this part, we don't add any restrictions, but we still have to carry over the original restriction we had before we plugged in, so we still cannot use 0. So this expression is equal to x, and our domain is x cannot be equal to 0.